Here is perfect problem 2 for Math 95. We're given a word problem and asked to solve it by setting it up as a rational equation. So the way we're going to do these is by kind of filling out this little grid, distance, rate, and time. Because there's so much information in this problem that it kind of helps to have it all summarized like this. So if you read the problem, I'm rowing and I'm going upstream for part of it and downstream for other parts. So I'll have a different speed, it'll take me a different amount of time. I'm going to need one row for when I'm going upstream and another row for when I'm going downstream. And then I got to take all this information and fill in my boxes. Well, let's see. D stands for distance, how far I went. It took me 4 hours. That's not how far I went. To row a total of 12 miles. Here we go. 6 of them were upstream, 6 of them were downstream. Sounds like a 6 and a 6. Rate, how fast was I going? Well, it's talking about the current, but how fast I'm going, it never tells me. That's what I'm trying to figure out. So I'm trying to figure out what my speed is, specifically my speed when there's no current. So I'm going to let how fast do I row when there is no current. I'm going to give that thing a name. I'm going to call it x. And that way later on when I solve for x, I'll be answering the question. So if x is the speed I row when there's no current, and there's a 2 mile per hour current, then when I'm going upstream, I'm not going my normal speed, I'm going 2 slower than my normal speed. And when I'm going downstream, I'm not going my normal speed, I'm going 2 faster. So my rate is x minus 2 and x plus 2 respectively. Finally, time. It took me 4 hours. All right, that looks like time. The challenge is that I don't know how much of it I spent going upstream and how much downstream. There's 4 hours total. This plus this is 4. Makes it tricky. The way you can get around that is say, all right, I don't know how much time I spent going upstream. Let's just call it T for time. Then I do know how much I spent going downstream. Because if I spent T going upstream, I spent the rest of it, so the total of 4 minus the amount I spent going upstream is what I spent going downstream. Now I got this grid all fixed. Okay, so I got to solve for x. I want to get this x all by itself. I know that, maybe it's time to switch colors, distance is equal to rate times time. All right, so I know that distance equals rate times time. That's the good thing. What makes this challenging is that I have 2 variables. Eventually I want to figure out what x is equal to, but I also have this t hanging around. So what my strategy is going to be is to first get rid of the t's. The way I'll get rid of the t is by solving for it in my formula. So if distance equals rate times time, then time must be equal to distance divided by rate. So I took this formula and I divided both sides by r and I got to down here. And why this is better, if I know that time equals distance times rate, then I know that this t right here is equal to this distance divided by this rate. Using the top row up here, I come up with this equation. I don't need to stop there. I can use the bottom row and come up with a similar equation. Time, 4 minus t, must be equal to distance divided by rate. Now I'm on the bottom row, so I'm talking about x plus 2. Using the top row, I come up with this equation. Using the bottom row, I come up with this equation. Maybe I even show that. This went here and this went here. 2 equations. That seems troublesome, but it turns out we need 2 equations because we have 2 unknowns. I want to solve for x. X is the question that I'm being asked. So I don't want there to be any t's in there. So what I can do is say, well, I know what t is equal to. It's 6 over x minus t. So let's take this equation right here, but instead of writing t, I'll write 4 minus what I figured out t was equal to. This is a kind of tricky substitution, so I'll repeat it. Down here, I copied what I have right here. It's identical to what I have right here, with one exception. Instead of writing the letter t, instead of writing 4 minus t, I wrote 4 minus 6 over x minus 2. Where did this 6 over x minus 2 come from that I replaced the t with? Right here. T is equal to 6 over x minus 2. So I have this equation. This is a rational equation. It has one variable, the variable x. So I can solve it. So really the challenge, probably the hardest part of these, is pulling out all the information and turning it into an equation. This equation is not especially easy to solve, but it's what we learned in the prior section. So if you understood the prior section, you're actually happy when you get to this stage because you're like, yeah, I got it from here. You set up this equation. You want to clear the denominator, so you find the least common denominator. In this case, the least common denominator is x minus 2 times x plus 2. So I'm going to multiply all three of these by x minus 2 times x plus 2. That'll give me 4 times x minus 2 times x plus 2 divided by 1 minus 6 times x minus 2 times x plus 2 divided by x minus 2 is equal to 6 times x minus 2 times x plus 2 divided by x plus 2. This looks a lot easier than this, but this is actually better because now I can cancel stuff out. I can cancel to the point where I have no denominators left. In this first term, I don't have any denominators. There's just the implied 1 there that I don't even need to write. From the second term, the x minus 2 and the x minus 2 cancel, so I have 6 times x plus 2. And that is equal to 6 times, see the x plus 2's would cancel, so times x minus 2. I can solve this equation. The basic idea is I want to combine like terms. It's hard to combine like terms right now because I have all the parentheses, so let's get rid of the parentheses. X minus 2 times x plus 2 is x squared minus 4. Negative 6 times x is negative 6x. Negative 6 times 2 is negative 12. 6 times x is 6x. 6 times negative 2 is negative 12. If I finally get rid of these parentheses by distributing the 4, I get 4x squared minus 16 minus 6x minus 12 is equal to 6x minus 12. A little bit low on room, so I'll jump up here. Now I want to get I want to combine like terms. Let's see, I got the 4x squared is my only x squared term. I got this minus 6x here. Got minus 16 and minus 12, that's minus 28. And that's equal to 6x minus 12. If I subtract 6x from both sides, I'd get 4x squared minus 12x. And if I added 12 to both sides, I'd get minus 16. Get to this stage. Since I subtracted 6x from both sides, this is gone. Since I added 12 to both sides, this is gone. If I can factor this, I can solve. The good news, you're like, oh, factoring these when the leading coefficient is a 1 is really hard. It's not a 1, it's hard. The good news is that there's a greatest common factor in here. I can pull out the 4 and I'm left with x squared minus 3x minus 4, which is a lot easier to factor. Just need two numbers that multiply to negative 4 and add to negative 3. That'd be negative 4 and positive 1. So I have something times something equals 0. Either 4 equals 0. No, that never happens. 4 is a number, it's not 0. X minus 4 equals 0, or x plus 1 equals 0. X minus 4 equals, I'm low on room again. Maybe I'll jump up top somewhere. Not 100% where, but I'll see where this arrow takes me. Maybe way up top. Sure. So where did I leave off? I had 4 times x minus 4 times x plus 1 equals 0. That means either 4 equals 0. No, it doesn't. It's a different number. X minus 4 equals 0, or x plus 1 equals 0. If I add 4 to both sides, I get x equals 4. If I subtract 1 from both sides, I get x equals negative 1. These are, well, two answers. That's weird. X is how fast I row when there is no current. A negative speed, that doesn't make any sense in the context of this problem. So in the context of this problem, the only solution that makes sense is this one over here. 4 is my answer. So when there's no current, I row at 4 miles per hour. Whew. All right, that's the end of this.